Time travel has been a staple of science fiction for decades, capturing our imaginations with tales of brave adventurers who defy the boundaries of time. From H.G. Wells's The Time Machine to the iconic Doctor Who, stories of time travel have entertained and fascinated us for generations. But while these stories may be works of fiction, the underlying question remains: could time travel be possible in real life? As scientists continue to probe the mysteries of the universe, they have uncovered some intriguing possibilities that suggest time travel may not be as far-fetched as it seems. In this video, we will explore the latest scientific theories and discoveries that bring us closer to unraveling the enigma of time travel. Join us as we embark on a journey through the twists and turns of temporal exploration, uncovering the secrets that may lie at the heart of this elusive phenomenon. Time travel is a concept that has fascinated humans for centuries. The idea of traveling through time and visiting different historical periods or even the future has captured our imaginations and inspired countless works of art, literature, and film. However, until recently, time travel was considered to be nothing more than a fantasy. That all changed when scientists began to explore the nature of time itself. One of the most significant breakthroughs in our understanding of time came with Einstein's theory of relativity. According to Einstein, time is not absolute but is relative to the observer's frame of reference. This means that time can be affected by factors such as gravity and velocity. As a result, time can pass differently for two observers who are in different circumstances. For example, if one observer were to travel at a high speed close to the speed of light, time would pass more slowly for them compared to an observer who was not moving at high speed. This phenomenon known as time dilation has been experimentally verified and is a well-established fact in physics. Another important concept to understand is that of spacetime. According to Einstein's theory of general relativity, space and time intertwined in a four-dimensional continuum called spacetime can be warped and distorted by matter and energy. This means that massive objects like black holes and neutron stars can create regions of spacetime where time is significantly affected. For example, near a black hole, time would appear to slow down for an observer compared to someone who was far away from the black hole. These distortions in spacetime can also create what are known as wormholes, which are theoretical tunnels that connect to different points in spacetime. If a wormhole were to exist, it could potentially allow for time travel by providing a shortcut through the fabric of spacetime. Despite these theoretical possibilities, many scientists remain skeptical about the possibility of time travel. One of the main reasons for this skepticism is that time travel appears to violate the laws of causality, which are the fundamental principles that govern cause and effect. If time travel were possible, it would raise several paradoxes, such as the grandfather paradox, which poses the question of what would happen if someone were to travel back in time and kill their own grandfather before their father was conceived. Such actions would create a logical inconsistency, since it would mean that the traveler would never have existed in the first place. Despite these paradoxes, some scientists continue to explore the possibility of time travel and have proposed various solutions to overcome the limitations imposed by the laws of physics. One such solution is the use of a device known as a Tipler cylinder, which was proposed by the physicist Frank Tipler in 1974. A Tipler cylinder is a hypothetical device that consists of a very long, thin, dense rod that is rotated rapidly. The rotation of the cylinder would create a warp in spacetime that would allow for time travel. However, the construction of such a device would require a huge amount of energy and resources, and its feasibility remains in doubt. Another approach to time travel involves the manipulation of quantum mechanics, which is the study of the behavior of matter and energy at the atomic and subatomic levels. Some physicists have suggested that it might be possible to use quantum phenomena such as entanglement and superposition to create time loops or closed time-like curves. These theoretical constructs could potentially allow for time travel by creating a self-contained closed loop in spacetime. However, the practical challenges of manipulating quantum mechanics on a large scale are enormous, and it is unclear whether time travel through this method would ever be possible. While the quest for time travel has captured the imagination of scientists and science fiction fans alike, it is important to note that the possibility of time travel remains highly speculative. Despite the theoretical work of physicists, there is currently no evidence that time travel is possible, and it may forever remain out of reach. Nevertheless, the pursuit of understanding the nature of time and the universe as a whole has led to some incredible discoveries and has pushed the boundaries of human knowledge. Whether or not we ever achieve the ability to travel through time, the journey of discovery is an endless source of fascination and wonder. Theories of everything. The quest to understand the fundamental workings of the universe has led physicists to develop numerous theories over the years. One of the most notable examples is Einstein's theory of general relativity, which revolutionized our understanding of gravity and the structure of spacetime. Another significant theory is quantum mechanics, which describes the behavior of matter and energy at the atomic and subatomic levels. However, despite the success of these theories, they have some limitations. General relativity breaks down at the singularity of black holes and inside of neutron stars, while quantum mechanics does not account for the behavior of gravity. To address these limitations, physicists have been working towards developing a theory of everything that would unify the fundamental forces of nature, including gravity, and explain the behavior of the universe at all scales. String theory is one approach to developing a theory of everything that posits that the fundamental building blocks of the universe are tiny vibrating strings. By studying the vibrations of these strings, it is possible to account for the properties of matter, energy, and the forces that govern the universe. While string theory is still a work in progress, it has the potential to revolutionize our understanding of the universe and may provide insights into the nature of time and the possibility of time travel. Wormholes. Wormholes are hypothetical tunnels that connect to different points in spacetime. They have been theorized as a way to potentially enable time travel by providing a shortcut through the fabric of spacetime. While wormholes are purely hypothetical and have never been observed, they are a natural consequence of Einstein's theory of general relativity. According to this theory, the presence of mass and energy warps spacetime, creating a curvature that can be exploited to create wormholes. To create a wormhole, it would be necessary to find a way to manipulate spacetime in such a way that the two ends of the wormhole are connected to each other in both space and time. This would require an enormous amount of energy and resources, and it is unclear whether such a feat is even possible. Despite these challenges, the concept of wormholes has captured the imagination of scientists and science fiction fans alike and has inspired numerous theories and speculations about the nature of time travel. Cosmic strings. Cosmic strings are hypothetical one-dimensional defects in spacetime that are thought to have formed in the early universe during the phase transition between a hot plasma and a condensate of matter. They are predicted to be extremely thin, but incredibly dense, and could potentially play a role in the formation of galaxies and other large-scale structures in the universe. While cosmic strings have never been observed directly, their existence has been proposed as a possible explanation for certain astronomical phenomena, such as the cosmic microwave background. If cosmic strings do exist, they could potentially be used as a way to manipulate spacetime and enable time travel. The immense gravity created by the dense strings could distort spacetime, creating a warp that could be exploited to create a wormhole or other time-traveling device. However, it is important to note that the existence of cosmic strings is still highly speculative, and there is no evidence that they actually exist or that they could be used for time travel. Time crystals. Time crystals are a relatively new addition to the realm of theoretical physics and were first proposed in 2012 by physicist M.C. Fisher and colleagues. Unlike traditional crystals, which exhibit a regular repeating pattern in space, time crystals have a periodic structure in time. This means that their atoms or molecules oscillate or vibrate in a repeating pattern that continues indefinitely. The concept of time crystals has been met with some skepticism. It appears to violate the second law of thermodynamics, which states that entropy wins every time. However, researchers have conducted several experiments that provide evidence for the existence of time crystals and have shown that they are not subject to the same constraints as ordinary matter. Time crystals could potentially be used as a way to manipulate time and enable time travel by exploiting their unique properties. However, this is still highly speculative, and further research is needed to fully understand the nature and behavior of time crystals. While the quest for time travel continues to captivate scientists and science fiction fans alike, it is important to approach this topic with a healthy dose of skepticism. While the theories and concepts discussed in this video are fascinating and thought-provoking, it is crucial to remember that none of them have been proven to be true. Time travel remains a highly speculative concept, and there is currently no evidence that it is possible. However, the search for time travel has led to some incredible discoveries and has pushed the boundaries of human knowledge and understanding. Whether or not we ever achieve the ability to travel through time, the journey of discovery is an endless source of fascination and wonder. What are your thoughts on the science of time travel? Do you think it will ever be possible? Let us know in the comments below. And don't forget to like and subscribe for more videos like this. Thanks for watching.